Okay, good morning, everybody. Probably like to get started here. Um, we are a few minutes early, but that's not an issue. Um, my name is Bryant Jones. I'll be moderating this amazing discussion on cannabinoid science, the cutting edge, and what's going on currently in the state of affairs. I am a horticultural researcher from the University of Minnesota. I study cannabis and the inputs necessary for great production, and further research is always necessary. I'll let these people introduce themselves. We'll start right here, madam.
Okay. So I'm Dr. Becky Lynn. I'm a gynecologist at Evora Women's Health in St. Louis. I'm also an adjunct associate professor of OBGYN at St. Louis University. And my research focuses on the effects of cannabinoids on sexual function and also in women, and also more recently on pelvic pain and painful sex.
I'm Mike Flemons. I'm the Vice President of Technical Business Development for a company called Source Technology, essentially a delivery system for functional ingredients. In this case, it would be cannabinoids and associated terpenes and other phytocannabinoids. My background is I'm a biochemist by training and have spent my 25 plus years under the auspices of the FDA through drug delivery, pharmacokinetics, veterinary foods and feeds, food, basically every silo of the FDA.
Good morning, Travis Chrisman, CEO of Coastal Labs. We have a extraction lab in Bend, Oregon. Also board member for Green Hygienics, publicly traded. We have an 800-acre USDA hemp farm in San Diego.
Good morning, Ben Sliva, Indianapolis. I have more than 25 plus years experience in academia. However, when working in academia, I was not able to touch cannabis or CBD or THC, so I started my own independent laboratory, and we are working on actual cannabis or CBD, THC, other cannabinoids, terpenes. We are mainly looking for real efficacy, real efficiency, because there is so many, I would say, bad players or bad products without any effectiveness. And actually in the lab, we have methods that we can really prove what is active and what is not active.
Excellent. So I know in my own lab we have very extensive methods for testing different cannabinoids in the field. And because this is such a vast topic, there's so many different ways that you can investigate cannabinoid science. So instead of trying to lay a very broad groundwork, I'd like everybody to speak specifically on how cannabinoid science is being used in your companies or in your labs.
So, I mean, I can answer that. This is, so because marijuana has been illegal federally, I find that the research on it is really limited, especially in women's health and sexual function. It's mostly on, rats and hamsters and things like that. And so I feel like in the last, 4 or 5 years, even as marijuana becomes legal in more states, both medically and recreationally, that the world of research is hopefully going to open up. I know that Canada, it's legal all throughout Canada, and what the not industry, but what we need, what the scientists need in the cannabinoid space is good quality, high quality research. So good controlled randomized trials, and we don't really have that. And so I feel like we're at the beginning of this boom where hopefully, I know it's going to take some time, but hopefully we'll be able to do more high quality research.
Hopefully standardization across the board will assist with that as well. What about yourself, Michael?
Yeah, I think a lot of the largest challenges facing the cannabis industry as a whole in regards to testing, or the point we just made, is the fact that human studies have not been possible until the Farm Bill of 2018 got signed off. The FDA is still not allowing it in food and beverage, but then that little nasty bug that we've been fighting has put the kibosh on. Now that green lighting human testing is available, recruitment is impossible. So how do you get a whole bunch of healthy people to randomly show up at the hospital to do a double-blind placebo trial? They're like, no way am I coming to the clinic or the hospital unless I'm dying at this point in time. So doing human studies has been exceptionally challenging recently. There are some companies that are sort of forging ahead. Animal models are great. Tissue cultures and plates, this is great, but you'll see a lot of papers where they talk about the results that are seen from a petri dish. And while that's great, how many biotech startups fail after phase 1 and phase 2 clinicals because those results tend not to translate very well. Another thing you're going to see is if you start doing research on these associated, the entourage effect, which it is what it is, or it is what it isn't really. When you look at all these factors, you'll see 3 studies where they'll go, we've combined CBD with myrcene, and here are our results, right? And then you look, everyone glances down and wants to see what the outcome is, and they pay very little attention. And most of the time it's because most people don't have an understanding of what the clinician is doing or how the trial is set up. So we've seen studies where you can take the same set of conditions and then get 3 radically different results, right? And so we're like, well, why? Why is that? And then we go back and we look, and at some point in time, someone has to present these compounds to something. They have to use a vehicle, right? So if you look at the GW Pharma model, they take the moieties of interest and they put them in sesame oil, which we know is literally like one of the worst things you can do from a bioavailability standpoint. And then you have other people that will work with ethanol. Well, at sufficient concentrations, ethanol is cytotoxic. So is that the best vehicle? And then you look at people like in studies, they'll use DMSO. Including it in many of the products. So it's an unfair assessment. But you take a DMSO platform, an ethanol platform, and an oil platform, and you're going to get 3 different results. The problem is the academician or the clinician or whatever the studying body has failed to generate anything associated with pharmacokinetic data, right? Who cares what the dosage is? Dosage is meaningless, right? Like 50 milligrams of X presented to the body, great, but how much is actually in you? Like I want to know the blood levels of these terpenes and associated compounds. And then many people will test terpenes at a level that is absolutely absurd. Like there's no way you're going to drink straight myrcene or limonene, or I don't think so. Like that's the equivalent dosage as taking a myrcene tablet. So the challenge is in the absence of this body of research, then we do have some research, but the research is scattered, and at least in my humble opinion, I think that a lot of the testing is flawed. And it's not backed up by understanding how much of these products are in your body. Now we know anecdotally it works, right? Like I can go to California and walk down and stand at a dispensary and ask all the hardcore stoners, have you ever eaten a mango before you've smoked? And they'll be like, yes, it's much better. How do we test that? That's the problem, right? But is there something about the myrcene content of the mango that's helping modulate the effects onto the ECS? Is it modulating it presynaptically or postsynaptically? Is it muting the effects? We don't understand. And we don't know. We haven't looked at what the myrcene levels in that person's body were prior to them consuming. So this understanding, we're literally a snowflake sitting on the top of the iceberg.
Quite literally. Yeah.
So,
would you like to add on?
Yeah, so we're in kind of the Coastal Labs, we're in the building phase, starting kind of from the ground up. We've gotten our licenses, we've got our GMP, our FDA registration, USDA. working on our ISO and our novel for selling in Europe. Our next phase is, we are going to go, there's a lot of labs out there that just make CBD and that's it. But we're going to have to legitly go after the clinical trials. And so, yeah, we got our certs. We're building out. We've got one facility that's built to spec. We also have an API certified isolate machine coming in. And then, yeah, once we do that, we'll start our clinical trials and go from there.
All these cannabinoids, the law of pharmacology apply to these cannabinoids. So it means you have to take one drug and you will have responders, non-responders, or partial responders. That is number one. Number two, when we started actually to test CBD in the lab, we purchased some CBD. It was CBD isolate. You have, COAs, certificate of analysis, all of these 99%, 98%. One was actually 102%, which percent is total nonsense. I was surprised to know how somebody can try to sell it, but okay. So we run anti-inflammatory assay. By the way, I will be explaining about these assays of cannabinoids and terpenes at 2:15 at the main stage, how we are doing it in the details. So anyway, what we run in the lab, anti-inflammatory assay, and suddenly all these, which supposed to have practically 100 or more of CBD, the anti-inflammatory activity up and down, up and down. So what now? So what we have rerun in the lab, we run HPLC, and we found that is what was on the COA is absolutely not true. Okay, so now we try to correlate it with the activity. And again, there is no correlation with the activity because you are focusing on one compound, and to have more compounds and to have effects which can be positive or negative for the activity. So that is for the, and we are still talking at the beginning. Experiments. We are going to preclinical studies, it means animals. The variability is started to jump up and down. Human studies, absolutely, clinical studies. That is the reason why for clinical studies you have to talk about, let's say, you have to have thousands of people to be really sure what is the real, what are the real data. So I don't want to put, some negative, spot on that one, but it's complicated. And we have to put more research and more resources together, to move in this field.
See, so as we can effects of cannabis in the body, or like we've been doing, just assuming that a certain percentage thrown at the body is going to have a certain effect. Could you speak a little more on the bioavailability and what that really means for concentration, and yeah, exactly. So,
okay, so bioavailability, okay, I'm gonna start from the beginning. Okay, let's say CBD. CBD bioavailability is really close to absorption. CBD absorption is between 6 to 8% because CBD is water insoluble. So what the people are doing, they are mixing CBD or cannabinoids with oils, okay? By that, you can increase it by threefold, let's say to something like 25%. It's still not enough, okay? So now, people are jumping to nanotechnology, emulsion and everything. We tried also, and we are doing that in the lab, but the problem is with everybody something like, okay, nanotechnology is great. Yes, it is. However, you can take, I'm gonna simplify it. This is your CBD, put sonicator in your jar, put some energy, and you are gonna have really teeny tiny nanoparticles. Okay, this is great, yes. And you can see some people, it is something like, great, show, they can put, this is the water, this is water-soluble CBD, and they are putting these nanoparticles there, and you can practically, it's dispersing totally. It looks like that one, but still it's not bioavailable because you have teeny tiny particles, but still they are insoluble. still, this is not exactly, it can deliver, but it's still insoluble. So there is, okay, other tricks. You can actually use autosomal nanoparticles. It's better because you can dissolve CBD in ethanol, prepare emulsion, and after that you can have nanoparticles. By that you have practically 100% bioavailability. And it's really tricky because it depends what are the emulsifiers, what are surfactants, and it's a little bit complicated. But again, what is important to go back to the lab and you can really test it and to see, this is the beginning. You can see if it's going to your body or not. Number two, according to the clinical studies, and it is coming actually from dietary supplements. You can have, okay, if you, this is FDA, to claim some real effect, you have to have clinical studies. Okay, let's say there was done, clinical studies was performed, it was published in peer-reviewed journal. Okay, scientifically it seems to be fine. It is fine, not seems to be, it is fine. But the question is what they used at the beginning. Obviously they used really pure or purified compound. And after that, this study is really linked only to this compound. But other companies, they are searching Medline, PubMed, they are taking this study, okay, this is great, it works, we are gonna buy something, mix it together, and our product is based on this clinical study. No, it's not true. And again, we have done it in the lab, different natural compound. We have to start in the lab to test it. Because if you can see it works in cells and it was published in clinical studies, you can expect, I'm not saying for 100%, that it really works. And I can tell you, we also tested in the lab compounds which supposed to be active, no activity. So this is, it's really complex process. I don't want to scare you, with science, but it's a little bit complicated. So
Yeah, no, that's why we're here. And I would like, because it's such a topic in the way it is, I would like to open the floor to any types of questions, and in any time that you feel that you need to jump in or slow the discussion down, please just, I think you can, if you can project your voice, that's just fine, or we can get a mic for you here. Thank you.
Okay, so it's complicated. Get it. How are any of you aware of any modeling or AI used to pull this data together to teach a computer to help us understand this? I mean, I can see where if we pulled the data, there's an opportunity for us to learn from each of the studies if we had the data in the
In my lab,
artificial intelligence.
inside the plant, there are a few innovations, but that you touch on what's going on inside the body.
Yeah, so I can kind of speak on that. We're talking to a group out in New York that has AI technology on that, but yes, there are groups out there, and I can connect you if you'd like to know more.
Yeah. As far as developing things inside the plant, there are infrared technologies that are being developed, laser technologies as well, to actually test for percentages inside the plant, which downstream does have an effect in the uptake in the body as well. Do you have a question as well?
Yeah, as far as kind of the bioavailability of the cannabinoids, would you perceive or think there's any difference of a product that's formulated, say, with a full spectrum where the cannabinoids are, naturally appearing together versus a formulation of combining isolates and having like a custom full spectrum, but it's really not a natural full spectrum?
I don't want to steal the show. I'm going to be talking about that one at 2:15 on the main stage. That actually, this is the beauty of science. That you can combine different ratios or different compounds, and you can identify what is the most effective. And we have methods for that one. If somebody.
Yeah. What about in women's science? Do you find a specific cannabinoid ratio or cannabinoids that tend to benefit women more, or?
Well, there's definitely limited data. The little data that's out there is CBD and THC. I haven't seen anything on any of the other smaller ones. I, as far as bioavailability and the question, I want to hear your answer. So I want to know. But in the women's space, no, there's just not a lot of data at all.
Are there things? What would you like to see developed as far as cannabinoid science and benefit of women's health?
Good clinical trials. That's what we need.
Yeah, yeah.
Yep, I'm an evidence-based academic person, and I just need some good clinical trials because I've seen a lot of good anecdotes, especially with pelvic pain, endometriosis, painful sex. We use CBD lubes in my office, but there's just not any good clinical data to support that. I still do it. I think CBD is super safe and all of that, but yeah, we need good clinical trials.
Yeah, should be at the
Sorry.
forefront. Go on.
And
Yeah.
that is, exactly because you mentioned pain, and that is, we are back, in inflammation. Because inflammation is actually it's responsible for practically everything. My academic life, actually, I was mainly studying cancer, and actually cancer is also, by the way, induced by inflammation. So what is really important to look for inflammation. And according to the pain, you are inducing pain, and if you induce pain, it translates to inflammation. So if you can block pain, if you can block inflammation, you can block pain. So that is.
To answer your question about the synthetic versus propagate strains that have specific levels of certain compounds in them. So the whole plant sort of myth, it's not, the body sees the chemical compounds. It doesn't see the source. So that's like saying that a cup of coffee from the caffeine from a coffee bean is more effective than a Red Bull. It's simply not true. The caffeine is the caffeine, right? So it doesn't matter if it comes from a plant or it's synthetically derived. We're talking about the chemical compound itself. Says it's 99% CBD, and then you test it and you find out it's not. Well, it was. CBD is inherently unstable. Cannabinoids are inherently unstable, and they isomerize all the time. It's an isomerization process that leads us into all those beautiful other isomers, CBV, CBG, CBN. CBG is the God particle, really. But the problem is that our analytical test methodologies, we bump up against limited detection. So if you have one molecule of CBD that isomerizes into 5 different compounds, you may see a small reduction in the CBD peak, but you don't see these peaks coming forward for the rest of the different isomers. And that's because they're below the limit of detection. It's a magic jar. You can't, to the point where you can't have fly away. They didn't crawl out of the can. They're still there. They're just in a different form, and then they're a different form that you can't see. So if you do differentiate fractionation and you pull it out, you can find them, that they're there. You can see that they are converting. An interesting aspect, if you smear them out onto white paper, they will get a chromophore. Sometimes you see this yellow develop, especially when you work with isolate. You'll get a yellow hue, or sometimes a red-blue color, almost a purple. These are really interesting chromophores, and it tells you that something's going on in there. It doesn't mean that anything's left. It just means it's changed. But yeah, I mean, the most effective, I think that's where we're going to go. Like we're going to get to the point where we're going to go, hey, it's so much more cost effective too. Like to strip myrcene out of myrcene is huge in mangoes and hops. Like, last time I checked, the beer industry only pulls out about maybe 15 to 20% of the terpenes in the hops when they dry up. So and that's waste material now. So there's an outlet for us to generate some of these terpenes that are much more cost effective. We're going to go back to boutiques and blend them, because remember that eventually this is going to fall under the FDA, right? So how do you create a monograph around the products that we want to work with? Like, Like myrcene is myrcene, right? The FDA has a standard. You can look up the monograph on myrcene. Here's the chemical structure, the purity, the boiling point, all these things. It doesn't matter where that myrcene came from. But now the FDA is challenged with saying, like, how do you create a monograph around these extracts that we're talking about and all the different terpene values? Like, we know that each extraction process, regardless of the varietal, is going to net us multiple different outputs, whether it's steam distilled or ethanol or CO2 or subcritical or supercritical. The same biomass in gives us 4 different outputs. But which one's right? Like, they're all extracts. How does the FDA manage that? They can't tell every extractor to pull every system that they have out and put a new system in so they can standardize it. These things it's the equivalent of a garbage truck, right? You've got all these cannabinoids, terpenes, phytocannabinoids, all this stuff. The contents of a garbage truck, I will argue, after the 4th of July look different than after Christmas. So, but they're still a garbage truck, right? Like lot to lot, crop to crop variation. This is the challenge that's before the FDA. This is the challenge that's before all of us sitting up here, all the growers, all the people who are studying this. Is 100% CBN. I guarantee when you get it, it's not. So now how do you address and account for that? How does it age? And go back. So it's an interesting concept. It's like, where are we going to go? Is it going to be this whole plant extract or a boutique synthetic blend? I think both answers are right, and neither one is more efficacious than the other because the body just sees the compounds.
You got a point to make?
Yes, and that is, only to add to that one, and that is exactly what is absolutely crucial, the testing of the biological efficacy. Because you can see something, some concentration on the paper, maybe that is number one. Number two, we are working also with growers. And, in a nice, beautiful cannabis plant, it's totally different amount of cannabinoids and terpenes on the top, on the bottom. And now it depends. You have, one field. And on the corner of the field, it's different amount of that actually inside. Because, irrigation, sun, whatever. And, it's kind of something like confusing because not everything is the same. So, and again, how to find what is effective. We have to test it for the real efficacy, for effectiveness.
It seems like Pandora's box is just, what we should call cannabis. Because the further we dig, I can't tell you, the more stuff happens. And a lot of these new cannabinoids that are quote unquote new, we've just found new ways of looking for them. They've been there the whole time. It's just now we can quantify them. And it boggles my mind every year, the new things that come out.
If I may, something, and because it's supposed to be cutting edge, okay? So now we are in the COVID era. And these are really beautiful recent data showing actually how cannabinoids are affecting COVID. Number one, if with COVID, it's something which is called cytokine storm. It means inflammation is going, berserk, up, totally up. Cannabinoids can block inflammation. This is kind of not the new news. What is kind of new, that actually some of cannabinoids, they can directly block the COVID virus, how it's attached to the cells. There is some specific receptor. I'm not going to go to the details, but it can block it. That is number one. Number two, or vice versa. Actually, some of the cannabinoids, they can really stop propagation or growth of COVID virus. And now, FDA, and I was mentioning that yesterday. Usually in dietary supplement industry, people are claiming, or companies are claiming something which is not true. Immediately FDA is gonna jump on it, and you're gonna have letter from FDA. You have to respond to the letter in 30 days, and you can discuss with FDA. However, in the COVID era, a lot of companies, not only in cannabis space, they started to promote some of their products against COVID. And no, in some cases not directly. It's enough to mention antiviral activity or some other studies focusing on COVID, and you are going to mention your product. You are going to receive the letter from FDA, and you are not supposed to respond in 30 days. You have to respond in 1 day. So this is, if you are producing something, be really careful with your claims and don't claim something which is really far away, or, try not to mention COVID or stuff like that. It's only,
Yeah, I know in my lab we were looking into possibly the euclidization of cells to produce these compounds, in a petri dish, so plant cells outside of being, in vitro. So that's something we could probably look back into. This was pre-COVID, but very exciting things. Is there any other comments or questions? Anybody have anything they would like to be clarified? Outside of that, any closing remarks from our
I have one
speakers?
question.
Yes, please.
So we were talking about how, the cannabis plant is full of cannabinoids and how it's the trash, what did you say? The garbage truck is, not the same July and December. And so my question is, we get a lot of our medicines from plants. So how and the difficulty with the FDA, because it's so different, is it just that cannabis is different from some of the other plants that we use as medicine? Or because I would imagine that if you have, I guess we were talking earlier about like paclitaxel, and you get it from the yew tree or something, and if the tree in the middle of the forest might be different from the tree on the edge of the forest. So how is cannabis different?
Well, in specific compounds, they're isolated. So for instance, there's a natural emulsifier that's pulled out of the bark of the soap bark tree, and it's licensed by ingredient. I think it's called Q Natural, but it's essentially an extract. So when you're looking at, they're actually pulling out that one compound. Now, do they have heads and tails on the bell curve? Yeah, they get a little bit more than just that particular extract. So much like isolate, that'll be, they'll look at compounds, not the whole plant extract, because it's just a muck and a mire. But it's interesting, but there are, anecdotally, we know people that smoke cigarettes, right? They do it essentially for the nicotine, but there's a lot of other stuff in there. Not always good, but there's a lot of stuff in there. But there's very few things that are FDA regulated that tend to be this mishmash of stuff. They tend to look at, when you take an Advil, you're taking that compound in a matrix. When you take aspirin, you're taking that compound in a matrix. Even mixtures are like two different separate chemicals that are put together, and that in itself is the huge hurdle and challenge in front of the FDA. Is they think of things as compound, and the FDA will go on record as telling you that if it came up today and it was not already approved, they would never in their life approve caffeine. So it's interesting. So that, there goes our morning existence, right?
We wouldn't have Tylenol either.
Right. We wouldn't have. There would be so many things that we wouldn't have. So I think that's the biggest challenge. Is
there a database of clinical trials like the NIH has?
yes.
Yes.
Oh yeah.
So all the clinical trials would be listed on the
Yep.
website. Okay, great.
There's about, I think, 200 to 300 last time I checked.
Where is that at? NIH.
Oh.
Yeah.
But
You're
also clinicaltrials.gov,
Yes.
you can see what's going on.
Yep.
And this way,
But there is some small problem, because when I was checking that, last time, it was something like 10 really open trials, because they are recruiting and main. Not still there, and talking about CBG or something else, we are a little bit still far away. But one comment to FDA. FDA is great. Okay, let's start like that one. But
in case there's anyone in the room.
but you have to realize one thing. These are rules, and For example, more than 50% of the drugs are coming from Mother Nature, from plants. And, talking about aspirin, that is what I was telling all the time to my students, if FDA should approve aspirin in these days, no way. There is so many terrible side effects of aspirin that it wouldn't be approved. However, aspirin is still one of the best drugs. So, this is, yeah.
The other thing it is a bit of a minefield for those people that are not officially, don't do this as part of their daily routine. There's one published paper that talks about beta-caryophyllene associating itself with CB2, I believe. It turns out the next three groups that came behind to study it basically disproved that one clinical study. But everybody and their brother writes about beta-caryophyllene attaching to CB2. We basically said it doesn't happen. But if you read every article published in the last 2 years, they all talk about it, even though it's been essentially touch the iceberg on bioavailability. There's a really great paper that got put out by a company called Caliper recently, and they standardized the dosage. Caliper. They standardized the dosage, and they just used 4 different delivery systems. So same group. Now, clinically, I would never publish it because I think the N was, I forget, it was very small. It wasn't, but the PK curves, all 4 are radically different. So that would be the one thing, if you ever just print out that graph and keep that with you at all times, and that should be your frame of reference to understand that. There's the same people with the same stuff, and they got 4 different results. Which one's right? Well, technically they all are. But so now you see study 1 uses this format and study 2 sees this format, and they come to different results. Well, they came to different results because they got different bioavailabilities. So,
Do you know the author or the journal?
it was literally, it's a promotional piece that they did.
So if I just Google it.
If you just Google it, yeah. And I said the N is small, but it's really interesting.
And something what is interesting, it's a little bit kind of different, but sometimes look, I don't want to insult some of my esteemed colleagues, but sometimes look, who publish these studies, and in the disclaimer, suddenly, they are supported by this big pharma company, speaking fees, blah blah, and everything. Okay, so now, really? So this is.
I may have independently
Yes.
vetted the results.
Actually learned a few things myself. I'm sure these people would love to be in contact with anybody if you guys have further questions or would like to touch base with them after the discussion. With that, I would adjourn and see you guys hopefully at our next discussion at 12:15, I believe. We were reading in here. And thank you guys.
Thank you.